This mission to explore Mercury, CNES has played a key role and overseen developments alongside all of the partners.
8 French laboratories and 15 nations are working together on BepiColombo and are accountable in particular to 2 major partners, the European Space Agency, who we're used to working with, and JAXA for the MIO orbiter, where we've had to familiarize ourselves with their methods as well as overcoming the language barrier. Fortunately, CNES has plenty of experience working with the world's spacefaring nations, so we got the job done.
The mission plans to conduct a series of in situ analyses of Mercury's magnetosphere and its interaction with the Sun, and to acquire data on the planet's topography and exosphere, eagerly awaited by the scientific community.
Mercury's very tenuous exosphere is what makes it so unique. Its gravity is too weak to sustain an atmosphere like on Earth. It's true that in France we're fortunate to have experts on Mercury's exosphere. In particular, the mission will be carrying instruments like Flybys, whose development CNES has overseen, with the LATMOS Atmospheres, Environments, and Space Observations Laboratory. We are supplying one of the elements that are going to help to explain the processes in this exosphere and how it manages to retain chemical elements from the planet. The French instruments are especially innovative. CNES has spun off R&T actions pursued over the last 10 years or so that the laboratories have perfected and will be flying and operating on Bepi in 2025.
France is a big player in the BepiColombo mission. 8 French laboratories have been involved in developing 11 of the 16 instruments for the mission's 2 orbiters. For this mission to explore Mercury, CNES has played a key role and overseen developments alongside all of the partners.
8 French laboratories and 15 nations are working together on BepiColombo and are accountable in particular to 2 major partners, the European Space Agency, who we're used to working with, and JAXA for the MIO orbiter, where we've had to familiarize ourselves with their methods as well as overcoming the language barrier. Fortunately, CNES has plenty of experience working with the world's spacefaring nations, so we got the job done.
The mission plans to conduct a series of in situ analyses of Mercury's magnetosphere and its interaction with the Sun, and to acquire data on the planet's topography and exosphere, eagerly awaited by the scientific community.
Mercury's very tenuous exosphere is what makes it so unique. Its gravity is too weak to sustain an atmosphere like on Earth. It's true that in France we're fortunate to have experts on Mercury's exosphere. In particular, the mission will be carrying instruments like Flybys, whose development CNES has overseen, with the LATMOS Atmospheres, Environments, and Space Observations Laboratory. We are supplying one of the elements that are going to help to explain the processes in this exosphere and how it manages to retain chemical elements from the planet. The French instruments are especially innovative. CNES has spun off R&T actions pursued over the last 10 years or so that the laboratories have perfected and will be flying and operating on Bepi in 2025.
France is a big player in the BepiColombo mission. 8 French laboratories have been involved in developing 11 of the 16 instruments for the mission's 2 orbiters. For this mission to explore Mercury, CNES has played a key role and overseen developments alongside all of the partners.
8 French laboratories and 15 nations are working together on BepiColombo and are accountable in particular to 2 major partners, the European Space Agency, who we're used to working with, and JAXA for the MIO orbiter, where we've had to familiarize ourselves with their methods as well as overcoming the language barrier. Fortunately, CNES has plenty of experience working with the world's spacefaring nations, so we got the job done.
The mission plans to conduct a series of in situ analyses of Mercury's magnetosphere and its interaction with the Sun, and to acquire data on the planet's topography and exosphere, eagerly awaited by the scientific community.
Mercury's very tenuous exosphere is what makes it so unique. Its gravity is too weak to sustain an atmosphere like on Earth. It's true that in France we're fortunate to have experts on Mercury's exosphere. In particular, the mission will be carrying instruments like Flybys, whose development CNES has overseen, with the LATMOS Atmospheres, Environments, and Space Observations Laboratory. We are supplying one of the elements that are going to help to explain the processes in this exosphere and how it manages to retain chemical elements from the planet. The French instruments are especially innovative. CNES has spun off R&T actions pursued over the last 10 years or so that the laboratories have perfected and will be flying and operating on Bepi in 2025.
France is a big player in the BepiColombo mission. 8 French laboratories have been involved in developing 11 of the 16 instruments for the mission's 2 orbiters. For this mission to explore Mercury, CNES has played a key role and overseen developments alongside all of the partners.
8 French laboratories and 15 nations are working together on BepiColombo and are accountable in particular to 2 major partners, the European Space Agency, who we're used to working with, and JAXA for the MIO orbiter, where we've had to familiarize ourselves with their methods as well as overcoming the language barrier. Fortunately, CNES has plenty of experience working with the world's spacefaring nations, so we got the job done.
The mission plans to conduct a series of in situ analyses of Mercury's magnetosphere and its interaction with the Sun, and to acquire data on the planet's topography and exosphere, eagerly awaited by the scientific community.
Mercury's very tenuous exosphere is what makes it so unique. Its gravity is too weak to sustain an atmosphere like on Earth. It's true that in France we're fortunate to have experts on Mercury's exosphere. In particular, the mission will be carrying instruments like Flybys, whose development CNES has overseen, with the LATMOS Atmospheres, Environments, and Space Observations Laboratory. We are supplying one of the elements that are going to help to explain the processes in this exosphere and how it manages to retain chemical elements from the planet. The French instruments are especially innovative. CNES has spun off R&T actions pursued over the last 10 years or so that the laboratories have perfected and will be flying and operating on Bepi in 2025.
France is a big player in the BepiColombo mission. 8 French laboratories have been involved in developing 11 of the 16 instruments for the mission's 2 orbiters. For this mission to explore Mercury, CNES has played a key role and overseen developments alongside all of the partners.
8 French laboratories and 15 nations are working together on BepiColombo and are accountable in particular to 2 major partners, the European Space Agency, who we're used to working with, and JAXA for the MIO orbiter, where we've had to familiarize ourselves with their methods as well as overcoming the language barrier. Fortunately, CNES has plenty of experience working with the world's spacefaring nations, so we got the job done.
The mission plans to conduct a series of in situ analyses of Mercury's magnetosphere and its interaction with the Sun, and to acquire data on the planet's topography and exosphere, eagerly awaited by the scientific community.
Mercury's very tenuous exosphere is what makes it so unique. Its gravity is too weak to sustain an atmosphere like on Earth. It's true that in France we're fortunate to have experts on Mercury's exosphere. In particular, the mission will be carrying instruments like Flybys, whose development CNES has overseen, with the LATMOS Atmospheres, Environments, and Space Observations Laboratory. We are supplying one of the elements that are going to help to explain the processes in this exosphere and how it manages to retain chemical elements from the planet. The French instruments are especially innovative. CNES has spun off R&T actions pursued over the last 10 years or so that the laboratories have perfected and will be flying and operating on Bepi in 2025.
France is a big player in the BepiColombo mission. 8 French laboratories have been involved in developing 11 of the 16 instruments for the mission's 2 orbiters. For this mission to explore Mercury, CNES has played a key role and overseen developments alongside all of the partners.
8 French laboratories and 15 nations are working together on BepiColombo and are accountable in particular to 2 major partners, the European Space Agency, who were
Greetings to all of our friends around the world, and welcome once again to Kourou, the home of the Ariane family, for today's live broadcast of Ariane Space Flight number 245. We're very happy to have all of you with us for this very important occasion because we are going to Mercury. That's right, we're sending Europe's first visit to the smallest planet closest to the Sun. At this hour, all the teams involved here at the space base back in Europe and in Japan are gearing up for liftoff, which is due to take place in just about 38 minutes from now. Our broadcast coming to you live, as always, from the Jupiter Mission Control Room here at the heart of the space base for a short mission, 26 minutes. If you're familiar with the broadcast, you might know we're starting a little earlier, but that's because we have a lot of information to pass along to you, so we hope you'll settle in and enjoy the ride. Also here is our French commentator, Thierry Bouvard. He's upstairs, outside on the terrace. Thierry, bonsoir.
Hi, Josh. Hi, everybody. Welcome.
Willkommen, Yokozo. Welcome for this joint launch between Japan and Europe under the banner of Arian Space, which we are going to live together. In front of me, within my line of sight, I can see there Ariane 5 and BepiColombo waiting patiently. But I think, dear Josh, that you have already a distinguished guest.
Yes, Terry, with us, Stefan Israel, Ariane Space Chief Executive. Welcome. Hello. We have just a couple of questions for you. First question, Flight 245, BepiColombo, is a key milestone for Ariane Space in space science and in exploration. What makes the launch so special for Ariane Space?
Yes, it's a very important mission for us tonight because it is the 51st mission we will deliver for ESA, the 23rd mission for exploration. We have done a lot of very important missions. We have in mind Venus and Mars Explorer. We have in mind Gaia, Rosetta. Tonight, this mission is the first European mission towards Mercury with the cooperation of JAXA. So we will deliver a key satellite tonight for a key mission.
For a key mission, right. Now, Ariane 5 will send BepiColombo to Mercury. We know that. Can you describe a little more, in a little more detail, what the mission is all about?
Yes, so today we have done all the operation linked to the final countdown. Yesterday we transferred the launcher to the launch pad. As you see on the control screen behind me, all is green, so we are now ready for the launch. The mission duration will be 26 minutes and 47 seconds, and it will tonight separate the satellite on an hyperbolic escape orbit, which is not exactly the standard GTO orbit. The satellite is light, it's 4 tons, and we have an increased velocity, which allows the satellite after to go to Mercury. It is a very, very, very long mission. 9 billion kilometers, 7 years, and the launcher will work 27 minutes to allow this very long mission. Okay. Anything else? Do you want to the deep space probes for in space coming up? Sorry, can
the deep space probes for Arian space, which are coming up?
Yes, so definitely tonight it's BepiColombo, but at the beginning of 2021 we will deliver for NASA in cooperation with the Canadian Space Agency and ESA. It will be the James Webb Telescope, and it will be also a very exciting mission.
And another international cooperation.
Absolutely.
Okay, Stefan, many thanks. Stefan is going back to work in the fishbowl, and we are going over to Terry, who has a guest of his own. Terry.
Yes, indeed, Joshua. By my side is Bernard Guillaume. He is the Assembly Integration Verification Engineer at ESA. Welcome to you. Good evening, Thierry. Yes, let's point out that the European Space Agency, via ESOG, has a very strong involvement. Yes, ESOG is indeed a very important partner for the BepiColombo mission, not only because ESOG has ensured the whole control of the mission throughout, or will throughout the whole mission of BepiColombo, but they were present right at the start of the adventure. They were behind the computations for the trajectory, demonstrating that the BepiColombo mission was feasible all the way to Mercury. So without ESOG, no BepiColombo. You will see later on that they are based in Darmstadt in Germany. So we understood that they were very much involved upstream, and during 7 years of the mission they will be overseeing to the flight. Yes, they will indeed be cherishing our little baby. So 7 years journey, and then BepiColombo will start working. You will discover this mission, which is really very complex. At the same time, it's taking us to one of the biggest enigma of our solar system, that is Mercury. There have been some previous visitors, Mariner 10 and Messenger, of course, but all this now will be refreshed with new data, new techniques. We'll discover this throughout this encounter. What I suggest we do is that we listen to Dominique Détain, who precisely will give us an update on this mission of BepiColombo. You will quickly understand that under this unique banner there are 2 different probes traveling together for 7 years, 1 European probe, but also 1 Japanese probe. Therefore, it is really teamwork that was conducted all these years that is now crowned with, in some 33 minutes from now, perhaps more, the liftoff of this Ariane 5 rocket. Thank you.
With a thin crust of rock surrounding a dense iron core, there's more to Mercury than there first appears. Temperatures on the heavily cratered surface range from around 450 degrees Celsius down to minus 180, and there are signs of past volcanic activity. Mercury has been visited twice, first in 1974 by NASA's Mariner 10 probe, and some 40 years later by Messenger, which spent 4 years in orbit. Messenger mapped the surface and even discovered strong evidence for water ice in shaded craters. But the mission also raised new questions about this mysterious planet, questions the BepiColombo orbiters will be trying to answer.
The big step forward for BepiColombo is the fact that we have two spacecraft, the European Space Agency spacecraft, which is designed to look at the surface of the planet and to study the planet in detail, and the second spacecraft is designed to look at the environment. And so having two spacecraft will enable us to do a great deal of new science compared to the previous missions.
Protected by multi-layered insulation, hand-stitched thermal blankets and a radiator to dissipate heat, ESA's Mercury planetary orbiter carries 11 science instruments. It will focus on studying the surface and internal composition of the planet.
We will provide the 3D images of the entire surface of Mercury. And then there will be a global mapping with a spectrograph for the composition. And it means that we will provide the composition within the spectral range covered by our instruments of the entire surface of Mercury.
A primary objective of the Japanese Mercury magnetospheric orbiter's 5 instruments will be to study the planet's magnetic field. The combined data from the orbiters will enable scientists to build up a picture of the magnetic bubble or magnetosphere surrounding the planet and the influence of charged particles from the sun, known as the solar wind.
With BepiColombo, with a two-satellite approach, we have one satellite, the MMO, sitting in the solar wind, and the other one is inside the magnetosphere, so we can see what is coming towards the magnetosphere and what is driving changes within the magnetosphere.
But the international science team will need to be patient. It'll take 7 years for BepiColombo to reach the planet and for Mercury's mysteries to be revealed.
It's not a mission, it's more like an adventure. I suppose scientific missions like this you don't decide overnight. You're true, Thierry. It's a very important adventure, a long one. It started back in 2006 with the development with the industrial partners, but in fact it started even earlier with scientists who started, European scientists and from other countries, started studying what could be discovered on Mercury, what was the benefits, what instruments were needed, and it takes years. Sometimes it's even the lifetime's work for a scientist, so that's quite a long adventure. And one of the apogees tonight with this Liftoff, well, Mercury remains an enigma. What is the state of our knowledge? What are the reasons behind this mission? What are the points that the teams need to confirm? Jean-Paul, with your guest, maybe you can give us some answers.
Yeah, we want to welcome 2 key players in the mission tonight. Professor Yoshifumi Saito, who is the director of JAXA's Department of Space Sciences, and Gunther Hasinger, director of science at ESA. Welcome to you both.
Thank you very much.
Gunther, let me start with you. I think it's a fair question. People want to know, it costs a lot of money, takes 7 years to get there. Is it worth it going to Mercury?
Okay, yes, that's a very good question, and I believe that this is a relative question depending on how much you are willing to spend. When you think about that, every European is basically every year spending about 10 euros for European Space Agency. This is about 1 cinema ticket. If you think about how much material for the cinemas we are actually producing, we are much more worse than a single cinema ticket. And I mean, not just jokingly, I think the inspiration and the fascination that we are creating in the people's minds, and in particular in the young generation, is really crucial in order to get people into professionals like STEM professions, but also the general public just to learn more, to get excited.
Okay, very good. You're going to have to share the microphone. Gentlemen, Dr. Saito,
yes.
we have 2 orbiters. This one is yours, is that correct?
Yes.
Okay. Now, this is called the MEO, or the
yes.
MMO?
Yeah.
Yeah, all right, tell us about that. What's its role?
Okay, the MEO's role is to understand the Mercury's magnetosphere. By 5 onboard experiment, MEO is going to measure magnetic field and surrounding plasma environment, and also including the solar wind interaction. And MEO also measures the sodium atmosphere of Mercury and also the dust environment. And Mercury's magnetic field is much weaker than our Earth, and the Mercury has no atmosphere. So in the extreme environment of the Mercury, the strong solar wind and strong solar radiation will easily interact with the Mercury's surface. And it affects the structure and dynamics of the Mercury's magnetosphere. So MEO is going to make the comprehensive measurement of the plasmas and resolve the still poorly explored Mercury's magnetosphere.
Okay, Gunther, which one is yours? Can we see yours here?
Okay, so ESA's orbiter is this one, MPO, and then ESA is also responsible for the transfer module, which brings us to Mercury, and also the sun shield to save MEO from the hot sun.
Okay. Sorry, I was going to ask you. Go ahead.
No, so you wanted to ask me what is inside?
No, I want to ask you what's the advantage of having two spacecraft.
Okay, I mean to have two spacecraft.
We'll get to the other question afterwards.
For the subject that Zeiser-san is mentioning, the magnetic field is a three-dimensional structure. It also depends on the solar wind. It changes, and so if you measure it from different angles, you can get much more information than just from a single angle. Okay. But also, the fact that we are basically looking at the same object from different times, also different instruments, is giving us a lot of additional information about the composition, the chemistry, about Einstein's theory of relativity, and so on.
Okay, good. Dr. Saito, last question, rather briefly, if you don't mind. Yeah. Why study the magnetic field?
Well, when the magnetic field of the Mercury was discovered about 40 years ago by Mariner 10 spacecraft, it was a great surprise. But the magnetic field of Mercury has not yet been fully understood. Okay. So making
this is going to help us.
Okay, making measurements, MEO will solve the mystery of the Mercury's magnetic field.
I'm sorry, I have to cut you off because we're out of time. Gentlemen, many thanks. Back to Terry now for a first look at the launch vehicle.
Thank you, Josh. Thank you. So let's get back to this launch vehicle still in the Guyanese night. Some numbers to define further this mission. So we'll look at this Ariane 5 and its passenger tonight. Ariane 5, this is a heavyweight version, the ECA. You will see some 55 meters high, like the 5 stages or 5 floors of Buddhist temple of Toji in Kyoto, the largest pagoda in Japan. It was built in 1644, therefore it's the equivalent of an Ariane 5 ECA. Liftoff mass is 780 tons. The initial thrust being provided by the solid rocket boosters flanking the Vulcan 2 engine. The fairing is 17 meters high, protecting the single passengers of tonight. This is BepiColombo, ESA JAXAT, 2 probes within 1 satellite. The carriage capacity required for this 101st Ariane 5 is 4 tons 207, 4 tons 49 alone for the BepiColombo satellite. This is all, Joshua, for the time being. We will leave you with a new guest, and not the least, telling us about the ESA expertise in terms of scientific missions.
Right, joining us tonight, ESA's Director General Jan Werner.
Good evening.
Hi. Another big scientific mission tonight. Now, I've heard you say many times that science is the backbone of ESA.
Yeah, science was the origin of ESA, and science is still the backbone. It is a special method how we are dealing with the science program. It is not top-down, which a Director General would love. It is bottom-up. That means the scientists are deciding what to do, and therefore science is really the backbone with new missions like the BepiColombo.
Mm-hmm. Now, with BepiColombo is part of a wider program of deep space probes. I'm thinking of the Jupiter-Ganymede mission, and there are others. Can you tell us BepiColombo's place in that program?
So if you look into our science program, we have a lot of scientific missions. Some are looking to planets, some are looking really to galaxies or other stars. So it's really part of this overarching program, which was called Cosmic Vision, and therefore we have a special director for the science mission. It's Günther Hasinger, whom you talked to earlier.
Mm-hmm. Okay, now ESA is, of course, a very big international organization, but it's not every mission that we have such a wide international cooperation, and I'm thinking in particular of the Japanese. Can you tell us a bit about
So
that?
ESA always tries to have international missions, so of course each and every mission of ESA is international because we have 22 member states, and the science program is paid out of what we call the mandatory program, and therefore all member states have to pay for these science missions. But in addition, we are always trying to have others on board. This time we have, of course, JAXA as a very predominant partner, but also NASA, and the Russians are with us at BepiColombo.
The space is a very cooperative business now. Would you say that no organism or no state can go it alone? Is that fair to say?
That's not the question for me. What is really the beauty is that space is above all the earthly problems, the earthly boundaries and borders, and therefore, even if we could afford such a mission alone, we like to do it together with partners because this shows that we can bridge earthly crisis by space.
All right, think of you're speaking to the average person in the street now. Sum it up for us. What's the most important thing, or maybe there are two or three most important things that people should know about BepiColombo?
For me, BepiColombo, the fascination is the most important thing. Because if you explain all these magnetic experiments and all of this, it's clear to go there for 7 years, a man-made or woman-made, but depends on that, instrument. This is really the fascination, and that was what Günther was saying. Fascination leads to inspiration, and inspiration to motivation, and this is what we need for our society.
Okay, terrific. Jan Werner, thank you so much. He's going to go back to work. We are going back to Thierry, who's going to look at the mission highlights and tell you everything you need to know about the mission coming up.
Thank you, Joshua. In particular, all is going according to plan. I can tell you that we are 14 kilometers away from this launch pad, number 3, where the launch vehicle has been waiting since yesterday as it was rolled out from its last assembly building after being given the go-ahead, and it's waiting there. We will now go through the major highlights that will be pacing this mission. There are no launch windows tonight, and liftoff is scheduled some 20 minutes from now. BepiColombo arrived in Guiana on the 24th of April, and this is when the campaign started, and everything is now ready for liftoff tonight. A few key moments, as we said: liftoff in Universal Time, 1 hour, 45 minutes and 28 seconds, 22 hours and 45 minutes and 28 seconds Kourou time, 2 minutes, 21 later, separation of the solid rocket boosters at 3 minutes 09, separation of the fairing. The launch vehicle and satellites will be followed by 5 successive tracking stations, as you all know, all of which will be on its journey to the east. Everything starting from here in Kourou with the Galileo station at 8 minutes 43, jettisoning of the main cryogenic stage, and in the same breath, 4 seconds later, ignition of the upper cryogenic stage. After a mission that will be quite short, the separation velocity will be 10,155 meters per second, and altitude will be 49 kilometers, and at 26 minutes and 47 seconds, separation of the satellite BepiColombo en route to Mercury, with a 7-year journey, and a fabulous one indeed. So we will meet again in December 2025 for the first data reported back from the 2 probes, one under the aegis of ESA and the other one JAXAT. So this around Mercury. As we heard earlier, if there's one area where international cooperations are primordial, it is the space industry. You cannot go it alone in space. Joshua, as you said, and now you are with one of the representatives of the Japanese JAXAT agency.
Right. BepiColombo, a joint mission, of course, between ESA and JAXA, the Japanese Space Agency. And with us now, Dr. Hitoshi Kuninaka, Vice President at JAXA. Thank you for coming in. We want to talk, we've seen that BepiColombo with ESA and with Ariane Space, part of a wider program of science projects. It's the same with you at JAXA. Can you tell us about some of those projects?
Yes, JAXA is now making the deep space fleet to investigate the solar system planet. And then so in 10 years, we will deliver our spacecraft from the from Jupiter to Mercury, and then so we will make the deep space fleet. In that sense, the BepiColombo is a very important role to investigate the Mercury region.
And it's also part of a very important international cooperation program on your side with the Europeans, which did not take place so much in the past. Is that right?
Yes, that's right. So BepiColombo is the JAXA's first major joint mission with ESA, and this task is very tough for us, but we have just accomplished, and we reached to the Memorial Day for launch campaign. And so this program fosters the good relationship and the mutual understanding between ESA and JAXA and Europe and Japan. So this framework will apply future space mission, CRISM, MMX, Destiny Plus, JUICE, and Athena and Spica, so on.
So you have a lot going for you in the future.
Yes.
With the international cooperation.
Yes, that's right.
And how are the relations with the Europeans? Good, I suppose?
Yes. ESA and the European people is a very important partner for Japan and JAXA.
Okay, tell us now, JAXA wants to reveal with this mission some of the physics, is that right, of Mercury. Can you give us an idea of what that's about?
Yes, that's right. So you may know only a few probes investigated Mercury in the past. Yeah. And then so Mercury is still mysterious. And then so that the BepiColombo approach, that is a very important and remarkable thing. So combination of Pepe and Mio, simultaneous observation will reveal the mysterious Mercury in detail.
When do we start getting some information? 7 years.
7 years later.
Or 8 years, right?
8.
Okay, you're looking forward to that?
Yep.
Okay, very good. Dr. Kuninaka, many thanks. Terry's going to take us to Devil's Islands now. They're lying offshore here from the space base. They're famous for their prisons. You might recall the film Papillon, but there's more to it than that.
Mais oui!
Yes, indeed, Josh, indeed. Much more. You know that we have taken to the habit during these video transmission to help you discover, in a special way, from the bird's eye view, some emblematic places of this Guyana we love so much. Therefore, today we are heading off to the Île du Salut, these islands off Kourou. We will be flying over this volcanic archipelago in a few seconds to discover, indeed, 3 islands which form this archipelago, the Île Royale, Île Saint-Joseph, and the Devil's Island, all of which are volcanic in nature and are attached to the Cayenne municipality, CNES being the owner of these islands. The Île du Salut owe their name to the tragic Royal French expedition conducted in 1763, the Choiseul expedition, which resulted in the death of some 12,000 people in a year, and the survivors took refuge on these islands where the climate was more friendly and mosquito-free. This is why they renamed them Île du Salut. Then the jail was built there to receive the first political deportees. Alfred Dreyfus and Guillaume Cesnac were the most famous of the prisoners jailed there. After the closing of the jail in 1947, the Guiana Space Center saw the light of day in 1965 and turned these islands into a strategic location because they are placed under the trajectory of the various launches installed on the Île Royale as early as 1969, launches to the north. One of the follow-up facilities was the Kinney Theodolite, which is an optical instrument for graphic trajectory location, and now has been turned into a Kinney telescope with as its mission to observe in the visible world and infrared any significant events from the liftoff to the first stage separation since the 1980s. Tourist has developed on the islands, and there has been a will to safeguard about the heritage with the buildings like the Chapelle Royale or the House of Dreyfus. Ile Royale and St. Joseph are open to visitors, which is not the case to this day for the Devil's Island, which is still closed to the public. So a favorite spot for tourists, these islands are reachable from the sea on a catamaran most of the time, and they offer a great variety of flora and fauna like iguanas, ara, monkeys, agoutis, and on the right season, I have a helicopter in my back, sorry, you can even discover, if you're lucky, the sea cows and the famous Guiana dolphins. A very nice species. So that's all, Joshua, about the discovery of Guiana as seen from the skies. What I suggest we do now is we get back on the ground and join you at the Jupiter Control Center, still being enjoying these beautiful images from the drone. Therefore, we will join you at Jupiter, and we'll hear about the flight desk, if I'm not mistaken.
Flight test is coming up, yeah. Meanwhile, the countdown is proceeding normally. If I can steal a look at my screen, 11 minutes and 28 seconds until liftoff BepiColombo on the Ariane 5. Now remember, according to the professionals, countdown is the most intense part of the entire campaign for the mission, the campaign lasting roughly 6 weeks when the satellites first arrive here. We're going to, as Thierry said, present some of the key players in the mission tonight. We like to do that in the beginning of the broadcast. The people making the mission happen. This is the Ariane Space High Command, also called the Flight Desk, headed up by Stefan Israel, whom you saw. With him, Roland Lagier, the Chief Technical Officer. And these gentlemen will make the call should anything unexpected come up, either before or during the mission. You might see them on the phones to the teams here across the space base or back in Europe. Ariane 5 is ready for her mission. You might recall also that Ariane 5 is the reliable workhorse vehicle and the senior member of the Ariane 5 with Soyuz and Vega. Ariane designed for heavier satellites like tonight's. Coming up next, you're going to see the green status panels, a very important part of the mission, both especially before the mission. They are a real-time summary of everything that it takes to prepare, to launch, and to follow Arian. You can see in the upper left of the screen there, it's behind us here in the hall on the far wall, the green status panels. We like to check them. There they are on the right from time to time before lifting off. And you see the color is green, which is just as it should be, so all is well. What they are is a go, no-go, red-green summary of everything that it takes for a mission, an Ariane or a Soyuz or a Vega, for that matter. Green means okay, red means the opposite. It's very simple. If you see a red in any of those, it means that we're going to stop the countdown. The space base covers a lot of area, and information from all these services, and you can see them there. Their safety and telemetry and the weather and the satellites and all that information coming in here to Jupiter from the different outposts, which is why we call Jupiter the nerve center and the real heart of the space base. Back inside Jupiter, we're going to take a look at some other key players. We're going to look at the satellite mission directors, also called the DMS. These are people responsible for the chronology of their satellites. They decide if their satellite is ready for launch. They follow the campaign step by step and its preparation as managers. They meet with their teams on a daily basis, of course, and give the okay for each stage of the satellite's preparation. Most of them, I would say, are technically oriented, and every Ariane Space customer will have one. You should be seeing Véronique Loisel of Ariane Space coming up, and you'll be hearing from her later on in another film. And all these players we've been mentioned are an important part of the launch base. And, by the way, what is a launch base? Well, it's a place where the launcher and the payloads are prepared. They are launched and monitored before and during the mission. This one, the CSG, happens to be the world's only dedicated commercial space base, Ariane Space operating the launcher family. Total mission time, as we mentioned, 26 minutes. Not exactly standard for an Ariane Space launch. Usually it's a little longer, 45 minutes or an hour, depending on the mission. Two other people you're going to be seeing today from Ariane Space, the mission director, Didier Said, working alongside the range operations manager, also called the DDO, tonight, Raymond Boyce, and it's his voice you're going to be hearing in just a moment when he's going to be calling out the 7-minute mark. That's an important milestone. We'll explain that in a moment. This person, the DDO, makes all the key announcement on the major milestones during the countdown and during the flight. And he will shortly call out the 7-minute mark, which is a key milestone. We're into the final moments of the final countdown as we wait for the DDO to call out the final
À tous de DDO, attention pour la séquence finale lanceur.
That's the DDO coming down to the 7-minute mark, and you'll hear him again.
Top, I0 moins 7 minutes.
All right, there we are. The 7-minute mark brings us into what's known as the synchronized or the automatic sequence. It's a key milestone representing really the tip of the iceberg, the final moments of final countdown. A complex series of operations running right down to liftoff, making the launcher autonomous. Our stage is set. I'm going to go up to the broadcast booth. While I'm doing that, take a look at a film on the launcher campaign to see how Arian is put together for the mission.
The VA245 launch campaign started in the integration building, the BIL, on September 6. After the stages assembly and the fluidic and electronical functional checks, the launcher was transferred to the final assembly building, the BAF, 2 weeks ago. The nominal planning has been adapted to take into account all the specificities of this single launch.
BepiColombo is also a totally atypical launch campaign carried out over 6 months at the Guiana Space Center. First of all, 4 Antonov aircraft brought the spacecraft's elements and equipment to French Guiana. In addition to these Antonovs, about 10 more containers arrived by boat. During the spacecraft preparation phase at the S5C payload preparation complex, BepiColombo occupied the 2 clean rooms, configured as one large room. The spacecraft teams proceeded step by step to unload and install the spacecraft modules in the clean room, to integrate the components onto these modules, to carry out electrical tests on the different modules, to meticulously install thermal insulation, which is carefully tuned by hand, to check the different onboard propulsion systems of the modules. Solar panels were fitted onto each module of the spacecraft. We're all impressed by the solar panel deployment test carried out across the huge structure built in the room. The filling of BepiColombo's different modules was carried out in between all these operations according to well-established schedule. The MMO, the Japanese Space Agency's module, was integrated onto the European Space Agency's module, the MPO. Then the assembled modules were installed on the MTM, the transfer vehicle. After its preparation phase, BepiColombo was transferred to the final assembly building to be integrated onto the launcher. Once onto the launcher, the finishing touches were carried out and the MOSIF, the sun shield, was integrated onto the spacecraft. The launch round rehearsal took place on October 15th, and the launch readiness review authorized the transfer of the launcher and its spacecraft to the launch zone on D1.
The final operations are now ongoing. Cryogenic fillings started 4 hours before the launch. Flight software has been uploaded into the onboard computers, and the synchronized sequence will be started around 7 minutes before liftoff.
Joshua Jempel back up in the broadcast booth with Johannes Benkoff of ESA, ESA's BepiColombo project scientist. Wonderful title. What's the job about?
Oh, hello and Ohio gozaimasu, Japan. Yeah, being project scientist of such a mission with 2 spacecraft and the collaboration between Europe and Japan is such a fascinating job, because you have dealing with all aspects of science, and you are the interface of the scientist, you deal with the engineers, you steer the science operation, so it's a great job.
Terrific. We'll hear more on that in a moment. But for now, we want to take the cameras up to the Launch Campaign Operations Center, where the teams are working, several teams up there, under the direction of this fellow, Raphael Beretta, who's the Launch Complex Operations Manager. Several teams up there, as we said. One is responsible for the ground operations, the other for readiness of the Ariane 5. The Launch Campaign Operations Manager heads up one group, and he coordinates with Mission Control for final authorization to launch, and when all the conditions are right, he then okays the automatic sequence at the 7-minute mark, which we just saw, in all about 100 people up there. How long have you been on the project?
Oh, I've been on the project for 15 years now, and for more than 10 years I'm the project scientist. And as I said, I'm the voice of the scientist, and that's a very complex thing, because on BepiColombo we have 16 instruments on both spacecraft, and all in all there's more than 30 sensors. And so not only technology-wise, also from the science, it's a very complex mission.
Okay, we're going to hear more from you when you come back, because Johannes has never seen a launch. Excuse me, he's going to go out on the terrace with all the other VIPs and give us his reactions, hot reaction, when he comes back. So don't get lost. See you later. The split screen image on the screen on the left, liquid hydrogen, on the right, liquid oxygen. These are the propellant feeder arms in the middle of the launcher. We'll get another shot of that when we pull back. They are putting fuel into the upper stage tanks, and you'll see the arms, and you can see them there in the center of the screen, coming out of the gantry into the upper stage. You'll see the arms pull back at 7 seconds before ignition. What are the people doing? They're going out onto the terrace there, because we have 2 terraces on either side of Jupiter that give a wonderful view onto the launch pad, which is about 15 kilometers away from us here, and that's where Johannes is gone. The DDO is going to call out.
Top, à 0 moins 1 minute.
And there we are. We're into the final 60 seconds as the crowd gathering on the terraces. Give us a chance to say hello to our friends at JAXA Tokyo, Airbus in Friedrichshafen, to our industrial partners, ESA, including ESOC, where we'll go momentarily, and CNES, and to all of you following the broadcast on the internet. We hope you are enjoying it. We're going to cut away now and let you listen to the DDO as he calls out the final countdown. Watch for the cryogenic arms to open and enjoy the liftoff.
À tour de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage Vulcain. Allumage 2EAP, décollage. Propulsion est nominale, la trajectoire est nominale.
The roar of our engines, a lot of fire, and with a BepiColombo on board, the DDO says all is well. The 2 boosters now providing 90% of our thrust, propelling the launcher along her trajectory at an ever higher velocity. 780 tons at liftoff, that's the mass. And to get that sort of mass off the ground, you need a lot of push. And push we have. She's burning 5 tons of fuel every second. 2.5 tons being burned every second in each booster, plus the core stage burning another 300 kilos of fuel every second. Ariane 5 putting on quite a show. And I can't wait for Johannes to come back and tell us his reactions. The sky is clear. You should be able to see separation of the boosters, maybe even separation of the fairing. We'll find out momentarily. Ariane 5 now following the program and the onboard computer, which gives all the orders, including stage separation. We'll soon see that in just about 30 seconds from now. We are in the first of 4 flight phases. The first 3 are powered, and we'll describe each in turn so you can follow. Right now, the first flight phase, the single first stage engine,
and the 2 boosters are burning. The boosters will each consume their 240 tons in just over 2 minutes, and in just about 10 seconds. They will be the first to be extinguished, and you'll hear that from the DDO, but you'll see that on the screen. You'll see the flame out there.
Pilotage calme, trajectoire nominale.
There it is. You see the main point of light in the middle when we come back to that, and the 2 points of light on either side are the boosters. That's what it looks like up there. There's another booster on the port side, of course, out of camera range. But you see the main point of light looks like the moon in the middle, and on the side the 2 boosters flaming out, and they will fall into the Atlantic. French Guiana, in part, chosen as a base for its opening on the ocean, launches posing no threat to the local population, of course. We're waiting for Johannes to come back. Before he comes back, our next milestone, separation of the fairing. That's next up as we continue to follow Ariane with looks like a ground camera or the naked eye.
Séparation de la
The launcher making her way. The DDO has called out separation of the fairing, and this is what that looks like. There's another half on the starboard side, which is falling into the Atlantic as well. We can separate the fairing now. Why? Because we're out of the dense layers of the atmosphere, of course, over 100 meters altitude. And you can see on the bottom of your screen on the left our altitude, 140 kilometers, and on the right our speed, 2.4 kilometers per second. We can also discard any dead weight. The fairing, excuse me, weighs 2.5 tons, so it's a good idea to get rid of it now that we can. The guests coming in after being treated to a wonderful sound and light show. On the left there is the satellite, the white boxes. Below that is the composite. One reason Kourou was chosen as the launch site was its nearby hills, where we could install radar and telemetry facilities. And that's where we're going now. This office, another place that is very active tonight, the CVI, or the Quick Look Telemetry Display Control Center. Now these teams have all the means for receiving, processing, storing, and analyzing all the data coming in from the ground stations. We'll have more on them along Ariane's flight path. The CVI is stationed atop a hill, and you just saw, not far from Jupiter. And right now these teams are following and analyzing all the key flight data coming in and reporting the flight status of the launcher back to the teams here in Mission Control. It's all part of the great information flow from points across the base to Mission Control, Jupiter, the Nerve Center. And Johannes has returned, and you are smiling. Tell us, how was it out there?
Oh, it was fantastic. I've never seen that before, and it was great.
Yeah, what impressed you the most? Was it the sound? Was it the light? Something else?
Oh, it was the brightness of the rocket when it went to the sky, and yeah, you could not see the rocket. It was like a big fireball going up to the sky, and it was really amazing.
Super. Did you see the separation of the boosters?
Yes, you could see it also.
Great. Nice. Okay, so if that doesn't make you want to come down here and watch a launch, ladies and gentlemen, I don't know what will. Next up, we want to find out...
Il reste 3 minutes de propulsion de l'EPC.
I imagine like most missions you had some problems. We're going to have to go to a film, but give us a first taste and we'll continue after the film. Any problem that you solved that you remember?
Oh, BepiColombo was a bumpy ride from the beginning. We had issues with the solar panels, which were not standing the combination of heat and solar radiation. And for that reason, we had to make them much bigger and tilt them by more than 80 degrees.
All right, we'll get the details on that in a moment. First, a film on the other milestone scientific missions launched by Arian. might remember some of those flights. Maybe you were even here in Jupiter for the launch, like Johannes was. We were just picked up by our first downrange tracking station. We promised some information on those. It's located in Natal, over the border in our neighbor Brazil, run by the Brazilian Department of Defense for CNES in an agreement with ESA. Now, we are building, BepiColombo is going to build on some of the science that was discovered by Messenger, the NASA project. How so?
Yeah, before the NASA project Messenger, we did not know much about Mercury. We only had data from Flybys in the 70s, and also there we could only see 1/2 of the planet. And even people, when they heard about BepiColombo, found it's a boring target. But all that has changed after Messenger, because we found out that Mercury is a fascinating, surprising planet with a lot of mysteries, which some things which we have never expected before. For example, formation temperatures were measured, which are much lower than expected. You would expect for a planet close to the sun, the temperatures are much higher, but actually we found they were much lower, comparable to formation temperatures of Mars. So there could be the idea that Mercury is formed somewhere else, so that would be fascinating.
What argument did they use to say that it's a boring target?
Oh, in the beginning they said
that sounds
they had no atmosphere, only a few craters. They didn't expect life on Mercury, and for that reason, maybe think that was boring.
Okay, we have had cutoff of the lower stage engine and separation of the lower stage engine, and as you can see on the animation, ignition of the upper stage, all on time. These are 3 commands given by the onboard computer in about 13 seconds. So we are now into the final powered flight phase. It's the single upper stage engine that will burn until plus 2510, or another 16 minutes roughly. The job of the upper stage, taking the satellite to its injection point, positioning it for separation, and then releasing it. That's its propulsion role. But she also has a second role, and that comes during Ariane 5's what they call ballistics phase. Our next film from ESA, an overview on the BepiColombo mission.
Fueled and almost ready to go, the final assembly of the BepiColombo mission to Mercury. A collaboration between ESA and the Japanese space agency JAXA, BepiColombo consists of 2 scientific orbiters, a transfer module to propel them to Mercury, and a sunshield. Protected by hand-stitched ceramic thermal blankets, the entire spacecraft is 6.5 meters high and will only just fit inside the fairing of its Ariane 5 launcher. Designed to withstand temperatures of up to 450 degrees Celsius, BepiColombo is one of the most technically and scientifically complex missions ever launched.
80% of our material needs to re-qualify for this mission because we hadn't tested before in that harsh environment. So it's a real challenge to go there and to bring 2 spacecraft in an orbit around Mercury.
The first challenge is getting to Mercury. Flying directly isn't an option. The sun's gravity means any spacecraft would be going too fast to make it into orbit. Instead, BepiColombo will take 7 years to reach its destination, combining solar electric propulsion with a total of 9 flybys of Earth, Venus and Mercury.
When we fly, we constantly brake against the sun because we fly into the inner side of our solar system. And when you fly towards the most heaviest element there, you constantly accelerate. We don't want that. This is why we decelerate.
Once they arrive at Mercury in late 2025, the orbiters will separate from the transfer module to begin their comprehensive scientific mission in 2026. With its 11 instruments, ESA's Mercury Planetary Orbiter will study the surface and internal composition of the planet. Meanwhile, JAXA's Mercury Magnetospheric Orbiter's 5 instruments will study the planet's magnetic field. Together, the orbiters will not only reveal more about Mercury, but also the history of the inner solar system.
Because Mercury is not tilted like Earth, it's spinning almost in the orbital plane. Therefore, there are some craters on the poles which never see sunlight. And in these craters, we found water ice.
And this water ice could be stable over millions and billions of years, and that's a fantastic thing also about Mercury.
ESA science and engineering teams have been working on BepiColombo for more than a decade. With a long journey ahead of it, the launch marks only the beginning of the next stage of BepiColombo's voyage of discovery.
I'm taking Terry's place for the moment out here on the terrace because I want to introduce to you Johannes Benkoff. You heard his voice, but you haven't seen him. So if we get the camera on him or the drone, well, there we are. I have a question for you, and I may have to cut you off because we're going to go to Ishak. But briefly, mission life, BepiColombo, 8 years. Why 8 years?
Yeah, it takes us a while to go there. We need 7 years to go to Mercury, and then it's 1 year of nominal mission. We hope that we maybe can get an extension of 1 year, because the spacecraft is also designed to last 2 years in an orbit around Mercury.
How do we get an extension?
Oh, you need to make a proposal with our agency, but if everything is good, then I think I'm quite confident that we will get this.
Okay, let's get the word from Ishak. We'll go to Darmstadt. We're going to speak with Paolo Ferri, head of operations there. Paolo, can you hear us? We're coming to you live from Kourou.
Yes, I can hear you very well.
Great, okay. We want to ask you a few questions. We don't have a lot of time. But first I want to ask you, what's the mood at Ishak? How would you describe it out there?
Well, everybody here is very tense, waiting for the signal to arrive. As you know, we lost the telemetry at the moment of liftoff, so we're not in contact with the spacecraft. And our job will start after the separation of the spacecraft from the rocket. So we are really looking forward to that moment.
So the mood from liftoff was what? Concentrated, focused. I don't want to say tense.
Yes. Yes, certainly tense, but everybody excited. We've been preparing for this mission for so many years. We were really looking forward to this moment. Now it's the time to go.
Okay, this moment is this moment. What happens next, both in the short term and in the longer term?
Yeah, in the short term, after we have acquired the first signal in a few minutes from now, we will have the team working here for about 2 to 3 days, getting the spacecraft ready for its long cruise to Mercury. There will be some activities like deploying antennae for the communications when the distance increases from Earth, and of course checking that all the systems are ready. Then there will be a more, let's say, a longer phase of a few months where we test the onboard systems, the payload instruments, and very important
Paolo,
will be
I'm going to have to cut you off. I'm terribly sorry. We have to go to a film, but Paolo Ferri, many thanks.
Okay, very good.
East. She will shortly be picked up by our downrange tracking station in Libreville in Africa. You're watching Ariane Space Flight 245. On the extreme right is BepiColombo. Now, what are we looking at? That's the sun shield on the extreme right?
Right, we see the sun shield, and behind the sun shield, the Japanese spacecraft is hidden.
All right, we'll be back with more. We're going to go to the film on JAXA and its role on the mission.
Konnichiwa. I'm Go Murakami, project scientist of BepiColombo in JAXA. Mercury is one of the most mysterious planets in the solar system because it is very hard to explore, and in the past, only 2 spacecraft reached there. But we think Mercury has key information to answer the questions about planetary formation, evolution, and its environment. So BepiColombo will explore Mercury and address such questions with 2 spacecraft and with various types of instruments. And our spacecraft, MEO, will focus on studying Mercury's environment because Mercury is exposed to the strongest solar wind in the solar system, and we want to understand the solar wind effect on planetary environment. We still need to wait 7 years for science data from Mercury, but I'm very excited at the launch. And I want to say arigato to all members.
Hello, I'm Hiroyuki Ogawa, thermal engineer of MEO. I'm working on the Mercury mission for 20 years from the beginning of BepiColombo project. The BepiColombo mission is very challenging from the thermal point of view. There have been many problems we have never experienced before. There is coming from the high temperature. We had to do many activities to solve them. The development was very, very tough. But now we are ready to launch. I'd like to say to everyone who has supported us, thank you very much for everything you did. Go BepiColombo, go MEO.
BepiColombo is an international collaboration between ESA and JAXA. When we start the collaboration, since we do not know each other, background and also the personality, and that caused many troubles. But after a few years, we know each other, our personality and their personality, and also the background, and then we can find the solution when we meet the problem. And now we are at the launch site, and just before the launch. I believe BepiColombo is a very good team, and the relation between ESA and JAXA is very good, and the relation between also the companies relating the BepiColombo is also very good. And we still have 10 years for the end of the mission, but I believe this good relation continues until the end of the mission. And also I believe BepiColombo is a model for the following mission between collaboration between JAXA and ESA. Thank you.
3 minutes to go in the upper stage burn. Let's talk about the physics, Johannes, the flybys, the gravity assist. They bring BepiColombo, we heard this morning, into the inner solar system, and we need 6 flybys around Mercury to get into its orbit. Is that right?
Yeah, that's right. You need, unfortunately, a lot of energy to go into the inner solar system because you have to brake against the sun. And you need either pump a lot of fuel to go there, but since we have a very heavy spacecraft, for us the enabling technology is also use the help of the planets to gain some energy by flying by of the planet. And on the way to Mercury, we need to have 1 flyby at Earth, 2 flyby at Venus, and 6 flybys at Mercury.
In our next film, a look at the relationship between Ariane Space and BepiColombo.
Uli, I know the involvement of ESA, JAXA and industries was considerable during all of those years of development and AIT, including during this 6-month launch campaign. Would you say the relationship between entities was a strength?
Pepe is a very international project with contributions of a large number of European countries, the United States, Russia, and of course Japan. As such, the teams running the development, procurement, and also the launch campaign are of a very mixed nature. Working together was for us a very normal business over the years, independent from the individual's nationality. Due to the common objective to bring a reliably working spacecraft into orbit, the team spirit was one of the driving elements to work successfully over such a long period as we have done for our project.
Could you explain in a few words what will happen from separation from launch vehicle up to Mercury descent?
Pepe will separate approximately 28 minutes after launch, performs the deployment of the solar arrays, the antennas and the magnetometer boom, and then, after a small commissioning period, starts its 7 years long journey to Mercury, where we will arrive in December 2025. To reach Mercury, we need the energy from 9 planetary flyby assists, 1 time Earth, 2 times Venus and 6 times Mercury itself, before entering the Mercury orbit. Arriving there, we will jettison the MTM first, then the spinning JAXA orbiter and the structure MOSIF, which protected the MMO during cruise, before we will lower the MPO into its lower orbit by chemical propulsion.
And once BepiColombo reaches Mercury in late 2025, the orbiters, as you saw, will be released and captured by the planet's orbit. The science doesn't begin immediately, though. We'll get Johannes to explain that in a moment. Science begins about 5 or 6 months after that. We're coming up on extinction of the upper stage, and you'll see on the left the nozzle will shut down. And we will be into the, there you are, and we are now in the final flight phase, the non-powered flight phase. We are coasting. With the upper stage engine shut off, we'd entered this coasting phase. Usually during this period, the composite is maneuvered and spun up in a series of operations ranging from a few seconds to a few minutes. This is to separate the first satellite and the Silda, which is the carrying structure for our second satellite, and then the second satellite in different altitudes and different positions. But we don't have a second passenger, of course, tonight. And we have just over 1 minute between extinction, which we just saw, and separation of BepiColombo. So the ballistics phase is very short. Now, we have about 3 minutes to go until separation. So a quick question. Mariner 10 discovered that Mercury, like Earth, has a magnetic field. The only other planet to have one. We don't know why.
That's correct. We don't know why, and it was a great surprise when it was discovered in 1974, because for such a small planet, nobody assumed that it could have a molten outer core, because you thought the planet is totally solidified. And that is what we would like to understand, how this magnetic field is formed, what is the effect of the sun on the magnetic field. And for that reason, we also have 2 orbiters which can distinguish between inner and outer fields. And we have a magnetometer on our spacecraft, the MPO, and 1 magnetometer on the Japanese spacecraft, MIO.
Your baby is scheduled to be separated in, I would say, half a minute. What's going through your mind now?
Yeah, I'm still not relieved.
You're going to be waiting for what you want to see, that everything happens. Right?
That's correct. I would like to see the separation going well, and then also the deployments afterwards.
And then we have to wait for confirmation, and we will get back to that. But it is a moment of high concentration as we wait the DDO's announcement. The mood here in Jupiter, like the mood in Isak, as Paolo Ferri told us, very concentrated, very focused.
Séparation BepiColombo.
There is separation. The DDO has called it out right away, and you can hear the applause. So there's the good news, at least on the scheduled program of events. However, we have to wait for confirmation. Can we get a reaction from you?
Yeah, I'm as relieved as the others, but still we are not there. We have to wait until we get the signal, and we have to wait until we have the successful deployment of our solar arrays and antennas and everything.
So, as they say sometimes in the political world, cautious optimism,
that's correct.
I guess, is the order of the moment. We have to wait for full confirmation of separation. to see if it has occurred properly. The signal will tell us that BepiColombo has been sent on her proper orbit. The solar arrays are due to be deployed about 74 minutes after liftoff, so we won't see that. But we have to see that the overall health is good, and the first signal acquisition could come in around, I think, 15 minutes. There are a few important items such as these to check before we can let the satellite officially, I guess, right, start its life and work. Ariane Space Course and ESA taking no chances, being very thorough. For this information to come in, for this confirmation, could take a few minutes, but complete success of the mission will be accomplished and, I guess, confirmed at that time. So while we're waiting, although they look pretty cheerful down there, smiles and handshakes all around, hugs and kisses, but as Johannes said, you still want to wait for the...
That's correct, but nevertheless, it's already a great moment to see that our spacecraft is now on its way and the science can start.
Okay, while we're waiting for the confirmation and then the speeches, you told me a great story about a selfie camera that was on board. You want to share?
Yes, unfortunately, we thought in the beginning it was a clever trick that all our Nadia pointing instruments, which are the instrument.
All right, we'll get back to that. Stefan Israel with the first of the speeches.
Ladies and gentlemen, distinguished guests, Ariane Space is delighted to announce that BepiColombo has been separated as planned on the targeted escape orbit and is now on its way towards Mercury. For its 5th mission of the year, Ariane 5 has performed flawlessly. Congratulations to all. Today's new success marks the beginning of a 7-year trip for BepiColombo, taking advantage of gravitational assistance from Earth, Venus, and Mercury. What an exciting journey. After the missions Mars and Venus Express, Rosetta, Herschel and Planck, Gaia, Ariane Space is very proud to have contributed to this new major scientific success. So I would like to express my deepest gratitude to ESA Science and especially to its director, Gunther Hasinger. Gunther, I think it was first time for you in CSG, so so it was a good time, obviously. And ESA DG Jan Werner. Jan, thanks for being with us tonight. After BepiColombo, we are looking forward to next Ariane Space mission for space exploration, the launch of the famous James Webb Space Telescope. Let me also thank ESA's partner for BepiColombo mission, the Japanese Space Agency, JAXA, which deliver the Mercury Magnospheric Orbiter. In this regard, I would like to address my congratulations to Mr. Hiroshi Yamamoto, JAXA Senior Vice President. I would like also to congratulate Airbus Defence and Space, which successfully delivered the Mercury Transfer Module and the Mercury Planetary Orbiter. I want to thank Airbus Space Systems and its CEO, Mr. Nicolas Chamussi, for being in CSG tonight with us. We have with Airbus many links. Airbus is the shareholder with Safran of Ariane Group. Airbus is also a provider for Ariane thanks to its subsidiary, and Airbus is the satellite manufacturer tonight. We have 3 more satellites to deliver by the end of the year with Airbus, so obviously you are important for us. Congratulations also to all other industry in the team and notably to NEC. The success of our 5th Ariane of the year would not have been possible without our European launchers dream team. Delivered to an escape orbit, this mission was a bit special. Our engineers have had to work hard to tailor it, showing the versatility of Ariane 5. So let me double congratulate all our partners for this new success. ESA and all the member states of the Ariane program whose support is essential. Ariane Group, Ariane 5 prime and first shareholder of Ariane Space, CNES, Ariane 5 Design Authority, and our DD partner here in CSG, our contractors in French Guiana, and all employees of the launch facility. Of course, I would like to pay my tribute to my Ariane Space colleagues for this new outstanding achievement, our first towards Mercury. So I would like now to welcome to stage our customers and partners. Thank you very much.
Ladies and gentlemen, it's really a great day, and I can tell you I'm really, really happy. Thanks to all who made this big journey so far possible. It's just the beginning of the trip, but it's already a great day for ESA. It's a great day not only for ESA. We heard already it's the first launch from CSG to another planet. It is also, of course, the first launch with an Ariane to another planet. When I thought about this mission to go to Mercury, okay, you know the distance from Earth to the Sun, 150 million kilometers. You know the distance of Mercury to the Sun, it's 50 million kilometers. So the difference between both is 100 million kilometers. I calculated the mean velocity of the spacecraft, and I came up with 28 days. And then I learned that they are not using this shortcut, but instead of that saying it takes 7 years. I said, what the hell are they doing? Why are they flying so slowly? I mean, it could be done in 4 weeks. But, and this is the secret, it is Giuseppe Colombo, who was really the father of this mission, because he said, if you do this, as a civil engineer would do it, then you are ending up directly in the sun. And this was not our intention. So we want to go to Mercury, and we want to orbit Mercury. And therefore, Giuseppe Colombo made a very special method, Flybys. And we have everybody is talking about electromobility. This is electric mobility, we have to say, in a very special way. We are not accelerating with electric mobility, we are decelerating. This is also interesting. So we have a solar electric propulsion on board. Now an interesting number to that. We have about 580 kilograms of xenon on board. The yearly production on Earth is 600 kilo per year. So we have just 20 kilograms rest for other activities for 1 year. So this is therefore, it's a very special electric propulsion, and it's therefore very important. And therefore I can just say, let us go together to Mercury, or in Japanese, Tuishi ni susei ni ikimashou. Go, Bepi, go. Thank you.
Thank you, thank you, thank you. Thank you very much to Ariane Space. Thank you very much to Jan. This is really breathtaking. We have today written history, and we have sent the most complex stack of spacecrafts that ever have been conceived into space onto a very long journey into an environment which is truly out of the Earth, truly out of this world, hot and dangerous, and we are going there where nobody else ever, well, not quite true, but anyhow, boldly go there. So, and this is the time to really say thank you. We have already heard a lot of thanks, but I would really like to thank all the hundreds and thousands of individuals who have made this success possible. Everyone, we are standing on the shoulders of giants, and the giants are all of you. And I would first like to thank the two space agencies, ESA and JAXA, for making this possible. I would like to thank our member states for bringing the finances and bringing the energetics and the instruments on board. I would like to thank industry, particularly the lead industries in Europe, ADS and TAS, and also NEC in Japan, for making this possible and leading teams of many sub-industries and engineers that really did technology development, which is unique and has never been tried before, to bring us there. The managers of the agencies are also a very important element of guiding and kind of controlling us through this very important and complicated exercise. I would like to thank the scientists, in particular the scientists who led instruments. You have heard that we have 16 individual instruments, and behind each of these instruments are teams and sub-teams and PIs and co-PIs, and I would really like to thank all of those. Their work will only start when we do the first flybys and then finally end by Mercury. We don't have to wait for 7 years. We can actually already get science when we are flying by Venus twice even maybe at the Earth flyby, we can at least calibrate the instruments, and all the Mercury flybys are also going on. And I would like to thank the operations teams who have actually worked very, very hard, trained, and are now taking over basically in this minute or in the last minute taking over the spacecraft. And I would last not least like to thank Ariane Space for bringing us to the second into the exact orbit that we need, and so on. And so a huge, giant leap for mankind has happened today, but a very, very tiny step for BepiColombo, which still has to go 1 billion, whatever miles, I forgot it. And by the way, I would like to check on the health of BepiColombo. How is BepiColombo doing? And I would like to give back to Isaac to tell us about where we are standing there. Paolo, do you hear us at Isaac?
We can see the telemetry, the team is checking the status, everything looks very good.
Wonderful. Thank you very much. Then I would like to hand over to, yes, Yamamoto-san. Thank you very much.
Okay, good evening. My name is Shizuo Yamamoto, Senior Vice President of JAXA. It's a great honor for me to be here for the marvelous view of the successful launch of Ariane 5 carrying BepiColombo spacecraft. Firstly, congratulations to the BepiColombo project team, ESA and JAXA, who have worked so hard for many, many years. I'm very pleased to share this memorable event today with ESA as our partner of the BepiColombo missions. Especially, I'd like to express our sincere appreciation to Director General Dr. Warner and the ESA team for their efforts of this remarkable cooperation over the years. I'd also like to express our gratitude to CNES and Ariane Space, Airbus Defense and Space, NEC, and Kourou launch operation team for the excellent launch operation at Guiana Space Center today. As already informed, BepiColombo spacecraft was separated from Ariane 5 and just began its long journey of more than 8 billion kilometers to the Mercury. It was a long flight from Japan to Guiana for myself, but it is nothing compared to the distance from the Earth to the Mercury. As for the mission of the BepiColombo, many scientists in the world are aiming to unravel the mystery of the Mercury by conducting a comprehensive observation of both its surface and interior using the two orbiters. One is developed by JAXA MMO, and the other one is developed by ESA MPO. These two orbiters will jointly travel to the Mercury for the next 7 years, and will start observation after arriving Mercury in late 2025. JAXA is committed to the success of the BepiColombo mission and other space science programs like Hayabusa 2, MMX, SLIM, CRISM, and so on. And international cooperation is essential for these missions. So So I strongly believe that through the success of BepiColombo mission, collaboration between JAXA and ESA, as well as Japan and European countries, will further strengthen and will contribute to the advancement of the future space program itself. Bon voyage, BepiColombo, and once again, congratulations and thank you so much.
Good evening, everyone in French Guiana. Good morning to our friends and colleagues in metropolitan Europe, and especially at the Airbus premises in all over Europe, and especially in Friedrichshafen. Thanks, Friedrichshafen. But also at ESOC in Darmstadt. And good afternoon to our friends and partners in Japan. Of course, I would like to warmly thank Ariane and my friend Stéphane, where are you? Ariane Group and their industrial supply chain throughout Europe for having developed, produced, launched such a reliable, powerful, and efficient Ariane 5 launcher, and relentlessly heading towards the Ariane 6. And Stéphane, as you said before, you still have 3 satellites to deliver for us until 2018, and you know how important a partner you are for us. Of course, I would like also to praise ESA's leadership, Jan, Günther, for having put together and led the development of such an important and magnificent BepiColombo mission while entrusting us Airbus as prime contractor. Of course, I would like also to congratulate our Japanese friends with whom we have interfaced over the last years to develop such an international partnership. And of course, a launch success is only possible thanks to the close coordination of CNES. Jean-Yves, thanks for being here today, of course, and the Kourou Spaceport teams. And last but not least, of course, I would like to pay a warm tribute to the Airbus teams throughout Europe and our industrial partners for their professionalism, engagement, dedication for having imagined, developed, integrated, tested, prepared for launch of such wonderful space systems. A very, very warm thank you to all of you. Please allow me, nevertheless, one last word on today's launch from another perspective. One could look at it from 2 different angles from an industrial point of view. Either the launch of another spacecraft developed in Europe, including contributions from the UK, leaving Europe to the unknown world of a remote planet. Or the launch of a paragon of what Europe can do at its best, in this case under the leadership of ESA, with a solid and truly European prime with a top-notch European supply chain. As far as Airbus is concerned, we are talking here about probably one of the most complex scientific satellites that we have ever developed so far, taking the benefit of almost all of our sites in Europe: Friedrichshafen, Stevenage, Toulouse, Ottobrunn, Bremen, Portsmouth, Tres Cantos, Paradas, Leiden, and probably missing some of them. And in very, very good cooperation with the friends from Thales and Aerospace in Italy, we'd like also a special mention to Kinetic for the electric propulsion subsystem, and Azure Space for the solar cells, which, you know, given the specifics of this mission and the need to develop dedicated products to cope with. This is indeed an amazing mission with this 9 slingshot maneuvers, as Günther, you have pointed out, around the Earth, around Venus, Mercury, serving scientific purposes and filling the inextinguishable need of man to discover new worlds, developed in an international cooperation environment, in this case with Japan. One of the best examples of leading forward, looking, ambitious and successful Europe. The one I personally love, and the one I will further support the expansion of. Good luck, Pepe. Happy to have received first news from your telemetry, and we'll meet again in 7 years from now. Thank you.
My name is Ishiguro, so I'm a Senior Executive Vice President of the NEC Corporation.
So first of all, all of you, congratulations on the successful launching of the Mercury probe, BepiColombo. I would like to express sincere gratitude, Senior Vice President of Yamamoto and all of the members of the JAXA, and also the Director General, Mr. Jan Banner, and all of the members of the ESA, and also the relatively government agencies, as well as enterprises which have contributed to this mission. And especially, I would like to express deep appreciation President Israeli and Ariane Space Company for the safety launching into the orbit trajectory. Within the BepiColombo project, NEC has been responsible for the system design, integrations, and support manufacturing of the satellite bus for the Mercury magnetospheric orbiter. Since 2005, NEC has been devoting its effort to the success of this project under the supervision of the JAXA together as one team for a long period of 13 years. It is scheduled to take another 7 years journey before the orbit reaches Mercury, and NEC is fully committed to support entire project, including the observation operation after the arrival. Today, here and now, I'm simply delighted to be celebrating a successful launch together with all of you. Thank you so much for your kind invitation to this remarkable occasion. Thank you very much.
Bien, bonsoir. I'd like to salute all those who played a part in the successful launch tonight. First of all, the 101st successful launch of Ariane 5 and BepiColombo on its way to Mercury. And if you're into celestial mechanics, we have amazing opportunities there because we're going to be flying by Venus, the Earth, Mercury. So looking forward to amazing years to come. So I'd like to congratulate the scientists because nothing would have been possible without them. So they are the ones who developed this mission, both in Europe and Japan, as well as the Airbus Defence and Space, as well as NEC teams played a key role in developing these, as well as the Arian group teams and JAXA teams and all the teams at the CSG who played a very, very important role in the successful launch that we've just witnessed. So we're very fortunate because this has been a golden year. This year we've had successful launches of Ariane 5 a couple of weeks ago, the cooperation within the JAXA, DNR and CNES with a mascot robots on the Guru asteroids, and we'll have a CFOSAT launch for to observe the winds and waves and Metacasi on the 26th of November. USAT landing on March, but the greatest of all occasions will be for the 6th of December 2025, because this is then that BepiColombo will orbit Mercury. So I remember back in 2004 when we launched Rosetta, I said, well, we'll meet again 10 years down the road, and the Odyssey goes on. So looking forward to following the BepiColombo arriving at the destination in Mercury. So it was the first time that Japan was departing towards Mercury. So we are leading ahead of the pack. Thank you.
Bien, mesdames et messieurs, donc pour clore cette soirée.
So, ladies and gentlemen, to close this evening, after again thanking all of you for this beautiful success, I would like to tell you that our next mission, again, will be an institutional mission for Europe, for EUMETSAT, one of the biggest clients of Arian, the weather forecast operated by satellite. So we plan to conduct this mission in the first days of November. The scheduled date is the 6th of November. We're still waiting for some more information from our Russian partner and Roscosmos to confirm the date, but today the operations are proceeding smoothly, and this is our objective. So see you very soon again at the Guiana Space Center.
So after all the good news and all the excitement, all the do is to say goodbye. Any last words?
Oui, remercier Bernard Guillaume avec qui nous avons pu commenter cette splendide mission pour nos amis francophones. C'était un très très grand moment. Quelle journée, Joshua, et surtout, quelle mission.
Right, Europe's the first mission to Mercury, the least known of all the planets in the solar system, but BepiColombo is going to change all that. So rendezvous back here in 2025. Meantime, for tonight, Ariane Space once again demonstrating not only technical know-how, but helping missions of a scientific nature, helping mankind in space exploration. I believe you had a poem for us?
Yes! Justement, un petit poème, un haïku pour rendre hommage à nos amis japonais et puis surtout souhaiter bon vent à BepiColombo qui est parti pour 7 ans de voyage. C'est un haïku de Nakatsuka Ipekiro. Je vous le livre, je trouve qu'il résume bien cette soirée. Sur la grève, j'ai beau me retourner, plus de traces de pas. Je trouve ça splendide.
That's a fine way to end it. Ariane Space's 5th launch for Ariane 5 this year, a rousing success. 4 more launches this year. You won't want to miss any of them. So until then, on behalf of everybody here at the Space Base, Joshua Jample with Jerry Bouvard, the poet, saying thank you for being with us. We hope you enjoyed it. We certainly did. And we look forward to seeing you next time. Goodbye, everybody.
À très bientôt.
Allumage et décollage.